Earth Systems 3209, Unit 2, Historical Geology. Text references can be seen in Chapter 6, Chapter 8, and Appendix A and Appendix B. Unit 2, Topic 4.3 focuses on mass extinctions. The focus of this presentation will be on relating the divisions of geologic time with two major mass extinctions in geologic past. When we look at mass extinctions in the geologic past, mass extinction episodes in geologic history where mass amounts of organisms are killed off. There are two such major extinctions that occurred in our past. These are recognized in Earth's history in the Permian-Triassic Boundary and also in the Cretaceous-Tertiary Boundary. The Permian-Triassic Boundary marked the end of the Paleozoic era, and the Cretaceous-Tertiary Boundary marked the end of the Mesozoic era. Text reference found relating to extinctions is found on page 238 in the text. The most widely accepted hypothesis for the extinction at the end of the Paleozoic era is the plate tectonic assembly of Pangaea, which resulted in a loss of habitat. We will discuss this extinction in more detail. The extinction at the end of the Mesozoic era was most widely accepted hypothesis explaining this extinction is contributed to the impact of the Great Meteorite and the corresponding disruption in climate. Other possible explanations that could explain extinctions in the past include a fall in sea levels, climate changes, prolonged volcanic eruptions, and periods of lack of oxygen in the oceans. All four of these are possible explanations that could explain why organisms have become extinct in the past. Let us focus on the Permian-Triassic Boundary at the end of the Paleozoic era. The possible explanation is the plate tectonic assembly of Pangaea, approximately 245 to 200 million years ago. When plate tectonics assembled Pangaea, this marked the greatest death of species recorded in the fossil record. 95% of all living species were killed off during this time. Trilobites and brachiopods are two species that died out, and they are no longer existing in the fossil record. The main reason which explains the Permian-Triassic Boundary extinction at the end of the Paleozoic era focuses on loss of habitat. With the collision of four land masses caused an increase in the elevation of the land, which we generally refer to as mountain building. This caused drier and colder climates where organisms cannot survive. Also, this reduction in the area of continental margins by 50% and dropped sea levels by 100 meters, thus reducing the living habitat for marine life to approximately 25% of the original. The living space for shelf marine life was thought to be reduced by as much as 75%. Therefore, only 25% of marine environments existed after the assembly of Pangaea, and 75% of all the environments for aquatic life was destroyed. This contributed to a massive loss of habitat for all marine life and marked the extinction of many marine organisms at the end of the Paleozoic era. When we look at the Cretaceous-Tertiary Boundary at the end of the Mesozoic era, possible explanations for this great extinction was a meteorite impact approximately 66 million years ago. This marked one of the largest death rates of species recorded in the fossil record. Approximately 77% of all living species were killed off at this time. The main reason that explained the extinction at the end of the Mesozoic era was contributed to the disruption of climate. The impact of the meteorite would have produced a dust cloud in the uppermost atmosphere that lasted for an extended period of time. This shielded Earth from solar energy and reduced global temperatures. Without the sunlight, plants would die, animals would then starve. This disrupted the entire food chain and caused it to collapse. So the resulting collapse in the food chain, along with the elimination of solar energy, reducing global temperatures, caused the majority of life at this period of time to die out. Majority of life that existed during the Mesozoic era were reptiles, and they were cold-blooded organisms. Therefore, the reduction in climates and the reduction in global temperatures contributed to the decline of these reptiles at that time. Two main points provide support that the meteorite impact was the main cause of extinction at the end of the Mesozoic era. Number one, a layer of iridium-rich sediment is seen at numerous locations throughout the world, whose age corresponds to the Cretaceous-Tertiary Boundary 66 million years ago. Also, number two, there's an impact crater found in Mexico that is dated to be approximately 66 million years old, which corresponds to the mass extinction. The extinction of the dinosaur is perhaps the most significant, seeing that these animals dominated Earth prior to the mass extinction. Let's look at some examples. What is the most likely reason to explain the extinction of dinosaurs? Our answers include disease, glaciation, global warming, and meteorite impact. As previously stated, the meteorite impact that affected the Earth at the end of the Mesozoic put the Earth into a global cooling state where reptiles, namely, pretty much died out. This extinction of reptiles and many other organisms at the end of the Mesozoic is thought to be caused by a meteorite impact. So the answer to the first question is D, meteorite impact. Geologic evidence suggests two major extinctions happened in the past. Between which geologic periods, or at the end of which geologic era, did these mass extinctions occur? When we look at the mass extinctions in geologic past, we see two mass extinctions. One extinction occurred at the end of the Paleozoic, and this sparked the Permamiantriassic Boundary. The main organisms that were wiped out at the end of the Paleozoic were the invertebrates. The second mass extinction to occur in Earth's geologic history was at the end of the Mesozoic. This was at the Cretaceous-Tertiary Boundary. And at the end of the Mesozoic, the main organisms that became extinct were reptiles. And the most important was the dinosaur. So to answer these two questions, at the end of the geologic time that marked the first extinction was the end of the Paleozoic, which was called the Permamiantriassic Boundary, where mass extinction of marine life, namely invertebrates such as trilobites and brachiopods, became extinct. And the second notable extinction in geologic time was at the end of the Mesozoic, which marked the Cretaceous-Tertiary Boundary. And at this boundary, reptiles became extinct, namely the dinosaurs. Example number 2. Explain how past events, such as a meteorite impact, could cause a mass extinction on Earth today. To look at this question, we need to relate a concept that we studied in Unit 1, and that would be uniformitarianism. And uniformitarianism states that the past, or the present, is the key to the past. So processes that occur today also occurred in the past and can also occur in the future. So when we look at the answer to this question, scientists believe that about 66 million years ago, a large meteorite collided with Earth, and it is believed to have created a mass extinction event. The collision caused huge amounts of dust and materials to be ejected into the atmosphere. This blocked the sunlight from reaching Earth, which in turn caused a quick and drastic change in climate. Plants and animals would not be able to adapt to this climatic change, and as a result, plants would die, which in turn would cause the food chain to collapse, resulting in loss of many plant and animal species. So this type of event could happen again in Earth's future. As we know, events which occurred in the past are similar to events which are occurring today. And this idea, called uniformitarianism, suggests that mass extinctions which have occurred in the past could also occur in the near future. Your turn. Take time and complete the following questions. Solutions will follow on the next slides. You can stop your recording now to prepare your answers. The questions read, a mass extinction of trilobites occurred at the end of which geologic time span? When we look at trilobites are invertebrate organisms which existed in a marine environment. Right now we are in the Cenozoic era, so therefore there was no mass extinction that contributed to the end of the Cenozoic. C choice, at the end of the Paleozoic, we have a mass extinction of invertebrates, and in this case the trilobites would be considered to be one of those invertebrates. So the answer to the first question would be C, Paleozoic. Question 2 reads, the extinction of dinosaurs marked the end of which era? Our choices: A, Archean, B, Mesozoic, C, Cenozoic, and D, Paleozoic. The dinosaurs were dominant throughout the Mesozoic era, and at the end of the Mesozoic, approximately 66 million years ago, the dinosaurs became extinct along with other reptiles that lived during that time. So the answer to this question will be B. To confirm, mass extinction of trilobites occurred at the end of the Paleozoic, and the dinosaurs became extinct at the end of the Mesozoic. In summary, there was 2 major mass extinctions in Earth's past. One such extinction occurred at the end of the Paleozoic, which was named the Permamiantriassic Boundary, and the cause of this extinction was thought to be due to plate tectonics. When the continents collided together to assemble Pangaea, 75% of all shallow water environments were lost. Therefore, only 25% of the remaining shallow water environments could be a suitable environment for life to exist. Therefore, that caused a lot of organisms to die out at that time. At the end of the Mesozoic, would be the second major extinction that occurred in Earth's history. Cretaceous-Tertiary Boundary marks the end of the Mesozoic. Scientists think the cause of this mass extinction was due to a meteorite impact which ejected much dust and material into the atmosphere, blocking solar radiation, which in turn killed plant life and caused the collapse of the food chain. This collapse in the food chain caused many organisms to die out at that time. There are also many other mass extinctions that occurred throughout geologic time, but the two mentioned above at the end of the Paleozoic and at the end of the Mesozoic were two of the most significant extinctions to have occurred in geologic past.